Welcome to this non-technical course for a brief introduction on artificial intelligence. This course covers a basic introduction about artificial intelligence and short quiz by the end of the session.
What am I? Can I help you, sir?
The moment we speak about AI, we start to visualize iRobot's movie, that is robots going to destroy humans.
Let's keep aside all our fictional assumptions because we are going to discuss about AI and its usage, and by the end of this video, your perception will change. Trust me.
Before we proceed to understand what is artificial intelligence, let's first understand what is intelligence. Let's take an example. There is a ball under the table and I ask the 1-year-old kid to fetch the ball for me. Since it's the first time for the kid, there is a possibility that the kid's head could slightly get hit by the table while picking up the ball. But the second time, the kid bends lower to get the ball and comes back with the ball without getting hit on the head. The kid has applied his natural intelligence to fetch the ball. And this is what is called natural intelligence. And when we add this human natural intelligence to a machine, it is called artificial intelligence. The father of artificial intelligence is Sir John McCarthy, who invented AI and presented this definition at a conference in 1956. The definition of artificial intelligence by Sir John McCarthy is the science and engineering of making intelligent machines. Although AI more refers to computer science, but now it's used by all departments like mechanical, automobile, aeronautical, healthcare, and many more. Let's understand with an example how AI is helping automobile industry, and the perfect example is Tesla, self-driving autopilot car. The Tesla car is in autopilot mode and the car is moving from one location to the other location automatically. It uses 3 sensors in the front, which is used to identify the pedestrians and other vehicles. Based on the distance between the car and the object, it's adjusting the speed, steering control as well. The same technologies are used in other systems such as flying drones, delivery robots, autonomous ships, and many more. The next important field that AI is useful is healthcare sector. AI's impact on healthcare sector could be used for medical diagnosis, surgery, drug discovery, administrative tools, disease prevention, patient education, health management, customer service, and endless other tasks. AI has a great impact on automobile, finance, retail, manufacturing, transportation, agriculture, customer service, education, healthcare, social media, aeronautical sectors.
Embrace the future with optimism. AI has the potential to improve our lives in countless ways, from healthcare and education to sustainability and innovation. Let's focus on harnessing the power of AI responsibly and ethically to create a brighter tomorrow for all. Please subscribe our channel. We will continue with part 2 about roadmap for AI and machine learning. Thank you for watching the video.
Artificial intelligence could advance in ways that surpass our wildest imaginations, and it could radically change our everyday lives much sooner than you think.
Artificial intelligence, AI, is rapidly changing the world, and the demand for skilled AI professionals is growing exponentially. If you're interested in pursuing a career in AI, understanding the necessary programming and mathematical requirements is crucial. Do you have these queries? What are the prerequisites for learning AI? How do I start studying for AI? How much mathematical knowledge is required? Which programming knowledge is needed? What is the best engine or tools or framework for AI? Why do we need to learn algorithms? In the previous video, we have discussed about what is intelligence, what is natural intelligence, and what is artificial intelligence. We also discussed about how a 1-year-old kid would use his natural intelligence to fetch the ball. The first time the kid tries to get the ball, he hits his head to the chair. But the second time, when he attempts again, he slightly bends over such that not to get hit and gets hold the ball. This is natural intelligence. Let's look at the roadmap towards AI. In simple words, AI consists of programming knowledge, mathematical knowledge, machine learning algorithms, machine learning tools, and AI case studies. This is the most common roadmap for most AI projects. Although there are other tools like deep learning, NLP, and many more, we will not discuss them now, but we will surely discuss this in the upcoming. Artificial intelligence, AI, is a rapidly evolving field, and choosing the right programming language to learn it can be challenging. Here are the top 6 programming languages for learning AI. Choosing the right language depends on your specific goals and learning preferences. Python offers a great starting point for beginners, while C++ provides high performance for advanced tasks. R is ideal for data analysis, while Lisp and Prolog cater to symbolic AI and logic programming. Java excels in enterprise applications, offering scalability and community support. C++ is popular choice for developing robotics applications and embedded systems. Offers exceptional performance and control, not as beginner-friendly as Python, but provides deeper control over the system. Python is widely used for machine learning algorithms, data analysis, and prototyping. Easy to learn, and beginner-friendly syntax and vast online resources make it accessible to newcomers. Abundant libraries like TensorFlow, PyTorch, and scikit-learn facilitate various AI tasks, adaptable to different AI projects and application areas. R programming language is a powerful language for analyzing and visualizing data, essential for data-driven AI models. Offers numerous libraries for statistical analysis, regressions, and data manipulation. It is widely used in academic research and scientific computing due to its strong statistical capabilities. Lisp programming language promotes a functional programming paradigm, offering different problem-solving approaches. Traditionally used for symbolic AI tasks like reasoning, logic programming, and knowledge representation. Lisp code can be concise and expressive, making it suitable for complex AI algorithms. Prolog is specifically designed for logic-based AI applications and reasoning systems. Allows you to describe what you want the program to do rather than how it should be done. Facilitates efficient representation and manipulation of knowledge, key for expert systems and natural language processing. Java is very popular for building large-scale and enterprise-grade AI applications. Promotes modularity and code reusability, beneficial for complex projects. Offers extensive documentation, libraries, and community support. Can be challenging for beginners due to its object-oriented nature and complexity. Artificial intelligence, AI, relies heavily on mathematics for its core functionalities. Building a strong foundation in specific mathematical disciplines is crucial for aspiring AI developers and researchers. The required essential mathematical knowledge for AI is linear algebra, vector calculus, probability and distribution, statistics, and matrix decomposition. Therefore, the roadmap says, in order to start the AI project, one must know a programming language and mathematical knowledge as prerequisite. Our next step is to learn machine learning algorithm, which we will cover in the next video. Thank you for watching. Please like, share, subscribe, and comment for us to understand your requirement better.
Artificial intelligence could advance in ways that surpass our wildest imaginations, and it could radically change our everyday lives much sooner than you think.
This non-technical course is about making your way towards the career path of artificial intelligence. In the previous video, we discussed about the required programming language and mathematical knowledge. In this video, we will discuss about machine learning algorithms and AI case study.
Well, I'm not pretty sure what's an algorithm.
Algorithm? Say that word again?
Algorithm.
Algorithm.
I have no clue.
Oh, an algorithm? Oh boy. I'm pretty sure. I know an algorithm has something to do with a Rubik's Cube.
We like a numbers?
I know Instagram's algorithm.
An algorithm is a set of guidelines that describe how to perform a task.
Well, I'm all about rhythm, right?
So, what's an algorithm? Well, an algorithm is a step-by-step method of solving a problem.
Let's evaluate our previous example, where the ball is under the chair and the kid has been asked to fetch the ball and hand it over to the man. So, the series of algorithm here is, number 1, the path has to be decided. Number 2, to go near the chair. Number 3, take the ball. Number 4, give it back to the man.
What is machine learning? Let me explain you in simple language. Humans learn from their past experiences and machines follow instructions given by humans. But what if humans can make the machines to learn from their past data and what humans can do it much faster? And this is what is called machine learning.
Many ways in which the machine learns. It could be either supervised learning, unsupervised learning, or reinforcement learning. Let's first quickly understand supervised learning. Suppose your friend gives you 1 million coins of 3 different currencies, say 1 rupee, 1 euro and 1 dirham. Each coin has different weights. For example, a coin of 1 rupee weighs 3 grams, 1 euro weighs 7 grams and 1 dirham weighs 4 grams. Your model will predict the currency of the coin. Here, your weight becomes the feature of coins, while currency becomes their label. When you feed this data to the machine learning model, it learns which feature is associated with which label. For example, it will learn that if a coin is of 3 grams, it will be a 1 rupee coin. Let's give a new coin to the machine. On the basis of the weight of the new coin, your model will predict the currency. Hence, supervised learning uses labeled data to train the model. Here the machine knew the features of the object and also the labels associated with those features. On this note, let's move to unsupervised learning and see the difference. Suppose you have cricket dataset of various players with their respective scores and wickets taken. When we feed this dataset to the machine identifies the pattern of player performance. So it plots this data with the respective wickets on the x-axis while runs on the y-axis. While looking at the data, you will clearly see that there are 2 clusters. The one cluster are the players who scored high runs and took less wickets, while the other cluster is of the players who scored less runs but took many wickets. So here we interpret these 2 clusters as batsmen and bowlers. The important point to note here is that there were no labels of batsmen and bowlers. Hence, the learning with unlabeled data is unsupervised learning. So we saw supervised learning where the data was labeled and the unsupervised learning where the data was unlabeled. And then there is reinforcement learning, which is reward-based learning, or we can say that it works on the principle of feedback. Here, let's say you provide the system with an image of a dog and ask it to identify it. The system identifies it as a cat. So you give a negative feedback to the machine saying that it's a dog's image. The machine will learn from the feedback, and finally if it comes across any other image of a dog, it will be able to classify it correctly. That is reinforcement learning.
Here is a detailed classification of machine learning for better clarity.
Step number 4 is machine learning tool or framework or engine. You can choose any AI tool to train the model. Lot of big companies are spending billions of dollars by developing the AI engines. Here are some most popular AI tools. Google TensorFlow is the most popular and trending AI tool. TensorFlow is a free and open-source software library for machine learning and artificial intelligence.
TensorFlow, an open-source machine learning framework famous for powering deep neural networks with high-level code. It was developed by the Google Brain team and first released in 2015. It's most commonly used with Python, but can run in other languages like JavaScript, C++, and Java. At its core, it's just a library for programming with linear algebra and statistics. As you know, the word tensor describes a multilinear relationship between sets of algebraic objects within a vector space, aka a multidimensional array. What makes it special is its collection of APIs for data processing, visualization, model evaluation, and deployment that make deep learning accessible to the average developer. It's extremely portable and is able to run on tiny mobile CPUs or microcontrollers with TensorFlow Lite, can run in the browser with TensorFlow JS, while the core library can scale up to multiple GPUs or run on tensor processing units, chips engineered specifically to run TensorFlow at a massive scale. It's used in medicine for object detection in MRI images, by Twitter to sort your timeline by tweet relevance, by Spotify to recommend music, by PayPal for fraud detection, in addition to many other applications like self-driving cars, natural language processing, and so on.
IBM Watson is also very popular AI tools and is widely used in health sector. Step number 5 is AI case studies. This is very important and useful for the career path of artificial intelligence. Case studies on topics like real estate price prediction, image recognition system, weather prediction, self-driving car, automation in music composition, diagnosis of medical diseases, identifying fake news, books recommendation. To conclude, what is required to get started is programming language, mathematical knowledge, machine learning algorithms, machine learning tools and AI case studies to get started for a career in artificial intelligence. Moving forward in our upcoming videos, we will further learn more in detail about machine learning, ML. And see you soon at the next session.
As we've touched on many times in this series, computers are incredible at storing, organising, fetching and processing huge volumes of data. That's perfect for things like e-commerce websites with millions of items for sale and for storing billions of health records for quick access by doctors. But what if we want to use computers not just to fetch and display data, but to actually make decisions about data? This is the essence of machine learning, algorithms that give computers the ability to learn from data and then make predictions and decisions. Computer programs with this ability are extremely useful in answering questions like, is this email spam? Does a person's heart have arrhythmia? Or what video should YouTube recommend after this one? While useful, we probably wouldn't describe these programs as intelligent in the same way we think of human intelligence. So even though the terms are often interchanged, most computer scientists would say that machine learning is a set of techniques that sits inside the even more ambitious goal of artificial intelligence, or AI for short.
AI uses a wide range of algorithms to make fast, reliable, and accurate customer predictions. Let's view some examples of these predictions. AI can predict the preferred merchants of a customer in a specific location. This is Mia. She is 27. She is single and she loves to travel. Mia travels to Istanbul. This is her purchase history. Recommended merchants in Istanbul based on Mia's purchase. Mia is now visiting Istanbul for the 4th time. The geolocation detect the event. Mia now starts to receive text messages on offers and discounts from all the merchants who she visited in her previous visits to Istanbul. Mia next travels to London. The geolocation now detects London, and Mia again starts to receive notifications on discounts and offers from all those merchants from whom she had made purchases in the past. AI can predict the preferred merchant of a customer. This is Adam. He is 42. He is married, and Adam is a businessman. To suggest products to users based on their browsing and purchase history, preferences, and behavior. The recommendation system analyzes customer data to identify patterns and trends in their purchase behavior and recommends products that interest them. This helps to improve customer satisfaction and increase sales by offering personalized recommendations that meet the needs of each customer. So, machine learning in simple words is input of data plus algorithms. Machine learning is a subset of artificial intelligence, which works based on self-learning algorithms using the past experiences or data set without being explicitly programmed. Self-learning algorithms are algorithms which will learn by itself and take its own decisions or predictions. Types of machine learning techniques, what are they? There are primarily three types of machine learning: supervised, unsupervised, and reinforcement learning. So to conclude, we have understood what are algorithms, what is machine learning, and we have seen the examples of usage of machine learning. Thank you for watching the video. In our next video, we will learn about the different types of machine learning in detail.
Hello everyone. Today's video, we will do a recap of what is machine learning. The new topic of discussion will be an example of supervised learning scenario. Next, we will understand the definition of supervised learning, classification versus regression model, list of classification algorithms, list of regression algorithms, and finally how to choose algorithms for your project.
Machine learning is a subset of artificial intelligence, which works based on self-learning algorithms using the past experiences or data set without being explicitly programmed. Types of machine learning techniques, what are they? There are primarily three types of machine learning: supervised, unsupervised, and reinforcement learning.
What is supervised learning? Using this example, let's try and understand what exactly is supervised learning.
There are totally 1097 species of vegetable recorded till date by the Biodiversity International scientists. Out of this, we have picked three most common species of vegetables, that is, tomato, bell pepper, and carrot. Next, we have labeled the data and specified its characteristics, features, and attributes, and created a data set. For example, for each vegetable, we have specified the colors that it would be available, the shape, size, the taste, if seeds available or not, region that it is grown, and much more information required to input the data. Once we have all the data ready, we start to label them based on the features and attributes, and we are exactly aware of the information being fed, and this is happening in a supervised manner. And this is why it is called supervised learning. The more data it analyzes, the better it becomes at making accurate predictions without being explicitly programmed to do so, just like humans would. This training data is also known as input data. The data classification or predictions produced by the algorithm are called outputs. The two main types of supervised learning are classification and regression. They are distinguished by the target variable types. Let's do a quick comparison between classification and regression. The most significant difference between regression versus classification is that while regression helps predict a continuous quantity, classification predicts discrete class labels.
Now, let's talk about classification data. In classification problems, the output values of target class are discrete. Target value must be belonging to a class. In this example, target values are fruit names which depends on color, diameter, and weight. In classification, we classify our data into classes, then can predict class for new data. This is how classification data looks like. In regression problems, the output values of target class are continuous. Target value must be integer or float. In this example, target value of house price is an integer value depends on bedrooms in house, floors, condition and location. So, our model will predict an integer value of house price by using these features. So, this is how our regression data looks like.
Okay. But how our data looks like in graph?
For regression problem, suppose you have only one feature x and target value y, and you are going to plot in graph for x equal to 1, y also 1, for 3 y equal to 5, and that's going on. We can draw a line or curve for predicting new data. But what's the strategies and maths behind this line? If you know, comment below. If you don't know, worries not. Soon I will make videos about this topic. So, subscribe my channel and click bell icon. But in classification problem, we will separate our data and make classes, and our data should looks like this. In this example, based on values of x, we make clusters for fruits. Target classes cloud be 2 or more than 2.
Some of the classification and regression model algorithms are listed here. Understanding the differences between regression versus classification algorithms is crucial for data scientists to solve market issues effectively. Accurate data predictions rely heavily on selecting the right models, ensuring high precision in the results. Selecting the right machine learning algorithm for a real-world problem involves understanding the problem, the data, and the algorithm's strengths and weaknesses. Here's a simplified step-by-step guide with real-world examples and use cases. Step 1. Define your problem. Start by clearly defining your problem. What are you trying to predict or solve? For example, predicting whether an email is spam or not.
Step 2. Gather and prepare data. Collect and prepare your data. Make sure it's clean and relevant to your problem. For example, a data set with thousands of emails labeled as spam or not spam. Step 3. Choose an algorithm category. Machine learning algorithms can be categorized into 3 main types: supervised or unsupervised, or reinforcement learning.
Step 4. Select specific algorithms. Now, within your chosen category, you'll need to select a specific algorithm. Here are some common ones with examples. For supervised learning algorithms, logistic regression or random forest. For unsupervised learning algorithms, K-means clustering or PCA could be applicable. Similarly, for reinforcement learning algorithms, Q-learning could be applicable. Step 5. Evaluate and compare. Now you need to evaluate and compare your selected algorithms using metrics like accuracy, precision, recall, or F1 score. Choose the one that performs the best on your data.
Step 6. Fine-tune and optimize. You will now fine-tune your chosen algorithm by adjusting hyperparameters. This process may require experimentation.
Step 7. Implement and monitor. Once you've selected your algorithm and fine-tuned it, implement it in your application. Continuously monitor its performance and retrain as needed with new data.
So, we come to an end of this session, and theoretically understood the concepts of supervised learning and the difference between classification and regression models. In the upcoming video, we will discuss about unsupervised learning. Thank you for watching the video. Please like, share, subscribe and comment.
Hello everyone. Let's do a quick recap of what is supervised learning. Supervised learning, also known as supervised machine learning, is a subcategory of machine learning and artificial intelligence. It is defined by its use of labeled data sets to train algorithms that to classify data or predict outcomes accurately. Types of supervised learning are classification and regression model algorithms.
We humans learn a lot of things by finding different patterns in the world. For example, by watching the cats and dogs playing, or watching a basketball game, or by watching a table tennis game. We learn by ourselves without anyone teaching us their patterns. This kind of learning, without anyone teaching us, is called unsupervised learning. Let's define unsupervised learning in simple non-technical way. Unsupervised learning in artificial intelligence is a type of machine learning that learns from data without human supervision. Unlike supervised learning, unsupervised machine learning models are given unlabeled data and allowed to discover patterns and insights without any explicit guidance or instruction.
Why do we need to understand the concept of unsupervised learning? Here are prime reasons for using unsupervised learning in machine learning. Number 1, unsupervised machine learning finds all kind of unknown patterns in data. Number 2, unsupervised methods help you to find features which can be useful for categorization. Number 3, it has taken place in real time, so all the input data to be analyzed and labeled in the presence of learners. And number 4, it is easier to get unlabeled data from a computer than labeled data, which needs manual intervention. Let's understand how AI can use unsupervised learning is by doing it ourselves. So let's take a look at an example of some flowers. The most basic way to model the world is to assume that it's made of distinct groups of objects that share properties. So for example, how many types of flowers are here? We could say there are 2 because there are 2 colors, red and yellow. Or we can look at the petal shapes and divide them into round petals and long petals. Immediately recognizing different properties like this and creating categories is called unsupervised clustering. We do not have labels, but we do have pattern assumptions. This is how we can program computers to perform clustering.
Here's a step-by-step breakdown of how unsupervised learning works. Number 1, data preparation. Gather the data set and pre-process the data. This could be images, text, sensor readings, or any other type of data you want to analyze. Clean and format the data to ensure consistency and compatibility with the chosen algorithm.
Number 2, selection of algorithm. Choose an unsupervised learning algorithm based on your data and desired outcome. Select an algorithm like k-means clustering, principal component analysis, PCA, or anomaly detection. Set parameters to configure the algorithm.
Step number 3, model training. Feed the data into the algorithm. This kicks off the learning process where the algorithm starts analyzing the data for patterns and structures. No target variable. Unlike supervised learning, there's no correct answer during training. The algorithm is exploring the data on its own.
Step number 4, pattern recognition. Feature extraction. The algorithm identifies key features or characteristics within the data that contribute to its differentiation. Similarity metrics. The algorithm calculates distances or relationships between data points based on the extracted features. Grouping and clustering data points with similar features get grouped together into clusters or categories.
Step number 5, model interpretation. Visualize the results. Use graphs, charts, or other visualizations to understand the discovered patterns and groupings. Evaluate the model. Analyze the quality of the clusters or the effectiveness of the dimensionality reduction based on your goals.
Step number 6, model application. Use the insights. Utilize the discovered patterns for various purposes, such as customer segmentation, anomaly detection, content recommendation, or data compression. Refine the model. Continuously fine-tune the parameters and settings to improve the performance and accuracy of the results.
Unsupervised learning is an iterative process. You may need to revisit previous steps and adjust parameters or even switch algorithms to achieve the desired outcomes. Different algorithms have different strengths and limitations. Understanding the principles behind each algorithm helps you choose the best fit for your data and purpose. By following these steps and understanding the underlying principles, you can unlock the powerful world of unsupervised learning and uncover hidden insights within your data. The two types of unsupervised learning are clustering and association.
What is clustering? Clustering is the process of dividing uncategorized data into similar groups or clusters. Or grouping unlabeled examples is called clustering. As the examples are unlabeled, clustering relies on unsupervised machine learning. What is clustering? Clustering is the process of dividing uncategorized data into similar groups or clusters. Or grouping unlabeled examples is called clustering. As the examples are unlabeled, clustering relies on unsupervised machine learning.
Hierarchical clustering is a method of cluster analysis which seeks to build a hierarchy of clusters, thus its name. It's a strategy where we start by treating each object as a singleton cluster and then successively merge or split groups until we reach a certain end condition.
There are two main types of hierarchical clustering: agglomerative and divisive. In agglomerative clustering, each object is considered to be its own cluster. According to a particular procedure, the clusters are then merged step by step until a single cluster remains. The divisive method is the opposite of the agglomerative method.
The other type of clustering is the partitioning clustering. Partitioning clustering, also known as disjoint clustering or hard clustering, is a type of unsupervised learning algorithm that divides a data set into non-overlapping groups, or clusters. Each data point belongs to exactly one cluster and cannot be part of multiple clusters simultaneously. There are mainly four types of partitioning algorithm includes as k-mean algorithm, k-mediate algorithm or portioning around Medoid's algorithm, Clara and Clarence.
What is k-means clustering? K-means clustering is an unsupervised learning approach used in machine learning and data science to solve clustering problems. K-means clustering is a widely used algorithm in the unsupervised learning domain of machine learning. It's known for its simplicity, efficiency, and effectiveness in grouping data points into distinct clusters. K-mean clustering further defines two subgroups, agglomerative and dendrogram.
Agglomerative clustering. This type of k-means clustering starts with a fixed number of clusters. It allocates all data into the exact number of clusters. This clustering method does not require the number of clusters k as an input. Agglomeration process starts by forming each data as a single cluster.
In the dendrogram clustering method, each level will represent a possible cluster. The height of dendrogram shows the level of similarity between two joined clusters. The closer to the bottom of the process, they are more similar cluster, which is finding of the group from dendrogram, which is not natural and mostly subjective. Benefits of unsupervised learning. Handles complex tasks. Unsupervised learning is more useful than supervised learning, where the initial input data is more complex and unstructured. No need to interpret labels. Machine learning engineers and data scientists are in charge of passing data sets through algorithms to train them, but they aren't needed to interpret labels for each data point. It derives meaning from raw data sets. AI tools can more quickly evaluate raw data when compared to a person. It identifies underlying patterns in unstructured data sets. Unsupervised learning can be used to identify common factors between large amounts of different data points. Works in real time. Unsupervised learning can work with real-time data to identify patterns. Less costly than supervised learning. Unsupervised learning does not require the manual work associated with labeling data that supervised learning requires.
Challenges of unsupervised learning. Results can be unpredictable. Higher risk of inaccurate results. Longer overall training times. Unsupervised learning models need a large training set to produce outcomes, and learning from raw data can be time-consuming. Lack of insight. Identifying the hidden patterns in large and classified datasets can make the training process more difficult. Computational complexity due to a high volume of training data. Human intervention is required to validate output variables.
Usage of unsupervised learning in applications. Clustering anomaly detection. This technique uses unsupervised learning to detect the performance of outliers in a dataset grouping without labeling the data. Association rule mining. Unsupervised learning identifies occurrence patterns in large datasets and how they affect each other. This application is often used to detect suspicious activity, disease symptoms, and customer shopping habits. Next, cybersecurity software trained in unsupervised learning can help detect when a cyber attack might occur as well as where and how. Customer segmentation. Marketing groups personalize their advertising strategies based on which categories its customers fit into. Medical imaging. Healthcare organizations use the unsupervised machine learning features in radiology and pathology devices to help detect and diagnose patients. Prognostic validity, often used in healthcare. This application groups patients with similar health issues and predicts how these patients will do over time. Recommendation engines. Organizations gather data about people's browsing, shopping, and viewing habits to provide them with personalized content.
Finally, let's know the difference between supervised and unsupervised learning. The main difference between supervised and unsupervised learning lies in the type of data they use and the way they learn.
Supervised learning. Label data. Uses data points with predefined labels or categories. Imagine flashcards with questions and answers. Supervised learning goal. Trains the algorithm to predict future outcomes or classify new data based on the relationships it learns from the labeled data. It thinks of learning to identify specific objects and images based on examples. Applications. Spam filtering, image recognition, sentiment analysis, stock market prediction, and more.
Unsupervised learning. Unlabeled data. It uses data points without predefined labels or categories. Imagine a pile of photos without captions. Goal of unsupervised learning is to discover hidden patterns and structures within the data, like grouping similar data points together or identifying anomalies. It's like exploring a new landscape and finding interesting features without a map. Unsupervised learning applications are used in customer segmentation, fraud detection, topic modeling and text analysis, image compression, and more.
A quick summary of what has been covered today. We did a quick recap on supervised learning and its types. We learned what is unsupervised learning and how it works. Types of unsupervised learning. What is clustering and types of clustering? What is K-means clustering? Benefits and usage of unsupervised learning. Difference between supervised and unsupervised learning. With this, let's end our session today. Thank you for watching the video. Please like, share, subscribe, and comment.
Hello everyone. Quick recap on topics covered in the previous session. We discussed about machine learning, types of machine learning, that is, supervised, unsupervised, and reinforcement learning.
Supervised machine learning relies on labeled input and output training data, whereas unsupervised learning process is unlabeled or raw data.
In this video, let's discuss about a type of machine learning that works on training method based on rewarding desired behaviors and punishing undesired ones. Yes, it's all about reinforcement learning. How does reinforcement learning work? Terminologies used in RL, benefits and challenges of RL. How is reinforcement learning different from supervised learning? Characteristic and types of reinforcement learning. Widely used models for reinforcement learning. What is Q-learning and final conclusion?
Imagine a maze with cheese at the end. A mouse navigates this maze, rewarded with cheese if it reaches the end, and nothing if it fails. This is a simple illustration of reinforcement learning. An entity called an agent learns to make decisions based on rewards and punishments. It's like a game of hot and cold where the agent learns to make the right moves, navigating its environment to maximize its rewards. So, in a nutshell, reinforcement learning is about learning the best action to take in a given situation through trial and error to maximize rewards. To understand it better, picture a game of chess. The board is the environment, the player is the agent. Every move the player makes alters the state of the game, bringing the player closer to or further from victory, the ultimate goal. If a move advances the player towards this goal, it's considered a reward. Conversely, if a move pushes them away from victory, it's seen as a punishment. This reward-punishment system forms the basis of reinforcement learning. With every game played, the player starts to understand which moves lead to rewards and which ones result in punishments. This understanding shapes their future moves. Through this process of trial and error, the player learns the best strategies to win the game, just as a reinforcement learning algorithm learns to make the best decisions. Now, you might be wondering, where does this come into play in the real world? Well, the applications of reinforcement learning are abundant and transformative. For instance, in the realm of robotics, reinforcement learning helps drones navigate complex environments or robotic arms to perfect their movements. In the automotive industry, it's the magic behind self-driving cars, enabling them to learn the best routes and make safe decisions. Even our leisure time is influenced by these algorithms. Ever noticed how your favorite streaming service seems to know exactly what you might enjoy next? That's reinforcement learning at work, curating a personalized viewing experience just for you. So, whether we're aware of it or not, reinforcement learning algorithms are constantly at work around us, making our lives easier and more efficient.
Reinforcement learning is a sub-branch of machine learning that trains a model to return an optimum solution for a problem by taking a sequence of decisions by itself.
The terms used in reinforcement learning is agent, environment, action, state, rewards, policy, value, Q-value. The details are mentioned here.
Robots with pre-programmed behavior are useful in structured environments, such as the assembly line of an automobile manufacturing plant, where the task is repetitive in nature. In the real world, where the response of the environment to the behavior of the robot is uncertain, pre-programming accurate actions is nearly impossible. In such scenarios, RL provides an efficient way to build general-purpose robots. It has been successfully applied to robotic path planning, where a robot must find a short, smooth, and navigable path between two locations, void of collisions, and compatible with the dynamics of the robot.
Another deep learning breakthrough came about. That is AlphaGo. It's a neural net that can play the game of Go better than the best humans. And the way that this neural net was obtained is by combining two styles of machine learning. The deep learning that I've been talking about and what's called reinforcement learning. So remember, in supervised learning, we tell the computer what to do, but with reinforcement learning, we're going to train the machine to win. So now we are in an interesting situation where we have AI systems that have discovered ways of playing Go that are stronger, different, original, different from how humans have been doing.
There are two types of reinforcement learning: positive and negative. Positive reinforcement is defined as when an event occurs due to a particular behavior, increases the strength and the frequency of the behavior. In other words, it has a positive effect on behavior.
Negative reinforcement is defined as strengthening of behavior because a negative condition is stopped or avoided.
Ever pondered over how a child learns to walk or how a bird learns to fly? Reinforcement learning, a type of machine learning, operates on a similar principle. It's about an agent learning to make decisions based on interactions with its environment, guided by reward and punishment. Reinforcement learning, in essence, is about learning from the consequences of our actions. Did you know reinforcement learning is not just one size fits all? Indeed, it's a diverse field with three main types: model-based, model-free, and hybrid. Model-based reinforcement learning is like a cartographer mapping out a new land. The agent, or learner, creates a model of its environment. It learns from this model, plotting out the best course of action based on the terrain it has charted. Then we have model-free reinforcement learning. Picture this as an adventurous explorer, relying on past experiences rather than a map. The agent learns directly from its experiences, without the need for an environmental model. Last but not least, there's hybrid reinforcement learning. This is a mix of the two previous types. It's like an explorer who uses both a map and personal experiences to navigate unfamiliar territories. Each type of reinforcement learning has its unique strengths and challenges. The choice between them depends on the specific task at hand and the data available. So, are all types of reinforcement learning created equal? Not exactly. We've seen that there are different ways to approach this complex field. Model-based learning is like a master strategist, creating an environment model to predict the future. Model-free learning, on the other hand, is like a seasoned traveler, relying on past experiences to navigate the present. And then there's the hybrid learning method, a blend of both strategies, leveraging the strengths of each. The choice between these types largely depends on the specific task at hand and the resources available. It's not a one-size-fits-all scenario. The world of reinforcement learning is diverse and exciting, opening up endless possibilities for the future of machine learning.
The three elements of reinforcement learning are model-based learning, value-based learning, and policy-based learning.
Model-based learning. In this reinforcement learning method, you need to create a virtual model for each environment. The agent learns to perform in that specific environment. Value-based learning. In a value-based reinforcement learning method, you should try to maximize a value function vs. In this method, the agent is expecting a long-term return of the current states under policy pi. Policy-based learning. In a policy-based RL method, you try to come up with such a policy that the action performed in every state helps you to gain maximum reward in the future.
Number 1, reinforcement learning, RL. Agents continually learn and adapt through trial and error in dynamic environments. This allows them to handle unforeseen situations and even improve their performance over time.
Number 2, unlike supervised learning, RL doesn't require extensive labeled data, which can be costly and time-consuming to acquire. With only a reward signal, the agent can learn effective strategies.
Number 3, RL excels at challenging tasks where the optimal solution is unknown beforehand. This makes it ideal for applications like robot control, game playing, and resource management.
Number 4, can be efficiently scaled to handle large and complex problems for parallelization. Number 5, can learn generalizable skills for abstraction and transfer learning. Number 6, reinforcement learning agents can learn to optimize their actions with limited resources. Number 7, some RL methods allow for interpreting the decision-making process of the agent, providing valuable insights into the learned policies and strategies.
The usual challenges with reinforcement learning algorithms that we face would be data efficiency, state and action spaces, exploration and exploitation, safety and ethics, explainability and interpretability, scalability and robustness, generalization and transfer learning. In reinforcement learning, regret refers to the difference between the expected cumulative reward of an optimal action and the actual cumulative reward obtained by taking a different action. Essentially, it measures how much a decision-making agent would have gained if it had always chosen the best action in hindsight.
One of the most important advantages of reinforcement learning is that it may be used to solve complicated problems. Reinforcement learning techniques, for example, can be used to train robots to perform challenging tasks like walking, running, and jumping. One of the main challenges of RL is that it requires a lot of data to learn from. Unlike supervised learning, where the data is labeled and curated, RL agents have to interact with the environment and explore different actions to find the optimal policy.
Here is the key difference between supervised learning, unsupervised learning, and reinforcement learning. Supervised learning maps labeled data to known output, whereas unsupervised learning explore patterns and predict the output. Reinforcement learning follows a trial and error method.
Ever wonder how machines learn? Let's take a classic game, tic-tac-toe, to illustrate. Reinforcement learning is the key. Imagine a blank tic-tac-toe board. The machine, or AI, makes a move. At this stage, it doesn't know what's right or wrong. It's exploring like a toddler learning to walk. Now the game progresses. The AI observes every move, every outcome. It starts to recognize patterns, understand strategies. It learns from every victory, every defeat. This learning process is iterative. The AI plays countless games, refining its strategy with each. It's like a grandmaster chess player studying past games to perfect their moves. This is a simple example of reinforcement learning. It's how machines learn to play games, drive cars, even diagnose diseases. It's how they learn from their mistakes and improve over time, just like humans. Remember, every tic-tac-toe victory is a step towards a smarter future.
1. Q-learning. 2. Deep Q networks, DQN. 3. Policy gradient methods, e.g., reinforce. 4. Proximal policy optimization, PPO. 5. Trust region policy optimization, TRPO. 6. Actor critic methods. 7. A 3Q LUMS, asynchronous advantage actor critic. 8. SAC, soft actor critic. 9. DDPG, deep deterministic policy gradient. 10. TD3, twin delayed deep deterministic policy.
Imagine a world where artificial intelligence systems learn from their experiences just like humans to make better decisions. That's not science fiction. That's the power of Q-learning in AI. Q-learning is a model of reinforcement learning, where AI learns from its past actions. It operates on a reward-based system, constantly refining its performance based on the results of its decisions. In other words, Q-learning equips AI with the ability to learn, adapt, and evolve, making it a game-changer in the field of machine learning. Q-learning can seem like a complex concept, but let's break it down into simpler terms. Imagine Q-learning as a treasure hunt. The AI is the explorer, braving an unknown territory, and the treasure is the best possible decision. Now, the Q-table is essentially the map. It's not complete from the get-go. Instead, it gets filled in as the explorer ventures forth, with each cell representing a possible action in a given state. The reward system is like hints or signs indicating whether the explorer is getting closer or farther from the treasure. Positive rewards signal the right direction, while negative ones suggest a wrong turn. The update rule is the compass, adjusting the explorer's course based on the rewards. It's an iterative process, with the explorer constantly updating the map and adjusting the course based on new information. So, Q-learning is essentially a trial-and-error learning method that helps AI make the best possible decisions. Now that we've unraveled the mystery of Q-learning, what are the key points to remember? Q-learning is a cornerstone of reinforcement learning, utilizing a reward-based system. It's iterative, constantly learning from past actions to enhance future decisions. This makes it a powerful tool for AI, enabling systems not just to perform tasks, but to learn, adapt, and evolve. With Q-learning, the future of AI seems even more promising. It's not just about machines performing tasks, but about them learning, adapting, and evolving to perform those tasks better. Have you ever wondered how an AI learns to play a game better than a human? The secret lies in reinforcement learning, a type of machine learning that takes its cue from behaviorist psychology. Here's how it works. An AI agent, interacting within a specific environment, executes actions. Each action either earns the agent a reward or incurs a penalty. This feedback loop of action and reward guides the AI's learning process. In essence, an AI agent learns to make decisions by interacting with its environment and receiving rewards or penalties. Reinforcement learning isn't a one-size-fits-all solution. It has three main approaches: value-based, policy-based, and model-based. In value-based learning, the focus is on determining the value of each state. Moving on, policy-based learning is all about directly figuring out the best action to take. Finally, model-based learning uses a model of the environment to make decisions. Each approach has its strengths and weaknesses, and the choice depends on the specific problem at hand. One key concept in reinforcement learning is Q-learning, but what exactly is it? Q-learning is a cornerstone of the value-based approach where the primary focus is on maximizing the value of each action. It introduces the concept of Q-values, a clever method that estimates the future reward of an action taken in a specific state. This allows the artificial intelligence agent to effectively predict and choose actions that yield the highest rewards. With Q-learning, an AI agent can learn to make the best decisions to maximize its rewards. So why does reinforcement learning matter in the world of AI? It's quite simple, really. Reinforcement learning is a game changer. It's transforming gaming, making robots smarter, and powering autonomous vehicles. It's the secret sauce that lets AI learn complex behaviors without any need for explicit programming. Think about it, a computer that learns from its own experiences just like a human. Incredible, isn't it? Reinforcement learning is revolutionizing AI, enabling systems to learn and improve from their own experiences just like us humans.
So, we come to end of today's session on reinforcement learning. Thank you for watching. Please like, share, subscribe and comment.